In the multi-level paging, the total physical address is divided into P and D. Again, P is divided into P1, P2. If the levels are two level paging, I'll divide the P into P1, P2. Then with the P1, first I will go into the outer page table. Then outer page table will return the next page table's address. Then with the P2, the second page, I will enter into the second page table. Then in that second page table, it returns the frame number. Then offset, with the help of the offset, I can able to identify frame and the offset, and it will generate the physical address. So this is the two-level page table scheme. Is it clear? So now inverted paging. Is it clear or not? Please respond in chat box. Is it clear? So now the multi-level paging is clear. All of you. Multi-level paging. Is multi-level paging is clear or not? What about the others? Only 2 members are responded. What about others? So multi-level paging means dividing the physical address into multiple levels to generate the physical address as fast as possible. The levels will depend on the number of pages or size of the page table. So now, very important concept. Another very important concept is inverted paging. The name itself is indicating inverted paging. It is exact opposite to the paging. ఇప్పుడు మీరు నాకు చెప్పాలి. Okay, ఇది process. Okay, and this is main memory and the CPU. Okay, so now in paging, so actual paging, first I have to divide this into pages with page size is equal to with some page size, with some page size, yes. So like this, we'll try to divide this into number of pages in paging, and then with the same page size, main memory will be divided. Main memory will be divided into frames. Is it clear or not? So the size of the frame is also yes. Is it correct or not? Is it correct or not? Okay, then you are generating page table. You are generating the page table. You are generating the page table. So now how many rows will be there here? It depends on the process. And who's this particular page table? This particular page table belongs to this process. If another process is there, this should also divide it into pages with size, yes, and they should have their own page table. So if it is P1 process and if it is P2 process, this is P1 process page, this is P1 process page table and this is P2 process page table. And if for example, if this is another process and it should also divide it into yes number of pages and its size is also yes, and that should you have to maintain another page table, and if it is PN and this is the PN page table. Is it correct or not? Is it correct or not? So this is the paging concept. This is the paging concept. Is it correct or not? Please respond. Is it correct or not? Okay. The process is divided into pages, and if how many number of processes are there, all the processes are divided into pages, and every process is having their own page table. Okay, and all the page tables are maintained in the main memory or dedicated registers or translation look aside buffer, TLB. Then I am trying to define the P and D, that is logical address, and I will look into this main memory, and ultimately I am generating the F and D. So this is the physical address. With this physical address, I am trying to enter into the main memory. But is it correct or not? Nobody is responding. Please respond. Is it correct or not in paging concept? In paging concept, is it true or not? Then I have some issues. How many page tables I have to maintain in the main memory? How many page tables I have to maintain in the main memory? Yes, if 3 processes are there, 3 page tables. If n processes are there, if n number of processes are there, then n number of page tables in main memory. Okay, so if number of processor goes on increasing, the number of page tables are increasing in the main memory. So these page tables are not the process. These page tables are the information about the process. Okay, so to maintain the information about the process, it is consumed the main memory. Okay, if n number of processes are there, main memory is consuming n page tables. So this is not the correct way. This is not the correct way. That is the major problem with this. That is the major problem. ఎందుకంటే మొత్తం టోటల్ గా how many number of pages that you can handle in the system? Please anyone? How many number of pages I can handle in a system? In a computer system? Please anybody? How many number of pages are handled by any system in a given point of time, in a particular given point of time? How many number of pages you can handle? Please think. ఇక్కడ చూడండి, నా arrow చూడండి. How many number of pages I can handle? How many number of pages I can handle? In a given point of time, how many number of pages a system can handle? It will handle only the number of pages that any process that any system can handle is depends on the main memory. Yes, exactly, depends on the main memory. నేను అదే అడుగుతున్నాను, how many number of pages that I can handle? ఎన్ని ఫ్రేమ్స్ ఉంటే అన్ని పేజెస్ కదా? Is it correct or not? number of frames or main memory size, no, number of pages are, if for example, are equal to small n. Number of frames in the main memory are equal to small n. So how many pages I can able to handle? Exactly. Is it correct or not? So ఎన్ని ఫ్రేమ్స్ అయితే ఉంటాయో అన్ని పేజెస్ కదా నేను మెయింటైన్ చేయగలను. సో రిమైనింగ్ పేజెస్ ని నేను మెయింటైన్ చేయలేను. సో దెన్ ఇప్పుడు మీరు n పేజెస్ గురించి ఇన్ఫర్మేషన్ మెయింటైన్ చేస్తే సరిపోతుంది కదా మెయిన్ మెమరీలోని. ఇక్కడ ఎన్ని పేజెస్ అయితే ఉంటాయో మెయిన్ మెమరీలోని అవి ఎవరికి సంబంధించినవి అనేది మెయిన్ మెమరీలో మేనేజ్ చేస్తే సరిపోతుందా లేదా? అలా కాకుండా ఎన్ని ప్రాసెస్లు ఉంటే n నెంబర్ ఆఫ్ ప్రాసెస్లు ఉంటే n డిఫరెంట్ పేజ్ టేబుల్స్ మేనేజ్ చేసాం అనుకోండి, ఈ n డిఫరెంట్ స్మాల్ క్యాపిటల్ n డిఫరెంట్ పేజ్ టేబుల్స్ లోంచి నేను మాక్సిమం ఇక్కడ స్టోర్ చేయగలిగింది స్మాల్ n నెంబర్ ఆఫ్ ఫ్రేమ్స్. సారీ, because small n number of frames are there, at max small n number of pages I can able to handle. That's the reason why you may have any number of processes. Please try to understand. You may have any number of processes. Okay, all are aside, and this is my main memory. This is the main memory. Instead of dividing the process P1, P2, P3 into pages initially, instead of that, I will do in the reverse order. So what may be the concept? What may be the concept? What is the alternative? What may be the alternative? What may be the alternative? Can anybody? Yes, divide the main memory first. In inverted paging, the name itself is indicating paging లో మనం ఎలా వెళ్తాం, ఇటువైపు వెళ్తాం. ఫస్ట్ ప్రాసెస్ ని పేజెస్ కింద డివైడ్ చేస్తాం, బట్ ఇన్వర్టెడ్ పేజింగ్ ఇట్ నుంచి స్టార్ట్ చేస్తాం. Inverted paging, the operating system will decide the frame size first. So instead of page size, the operating system will decide the frame size first. Okay, then with that size he will divide the main memory into operating system will divide the main memory into frames. Okay, so this is F0, F1, F2 and so on, Fn. Then what next? You have to tell. మీరు ఇది చెప్పారు అంటే మీకు పేజింగ్ ఎగ్జాక్ట్ గా కరెక్ట్ అర్థమైనట్టే. ఇప్పుడు నేను n ఫ్రేమ్స్ ఉన్నాయి. n ఫ్రేమ్స్ ఉన్నట్టయితే నేను ఎన్ని పేజెస్ ని మెయింటైన్ చేయగలను? మాక్సిమం n పేజెస్. సో అప్పుడు నేను ఎన్ని పేజెస్ ఇన్ఫర్మేషన్ ని నేను మెయింటైన్ చేయాలి? ఎన్ని పేజెస్ ఇన్ఫర్మేషన్ ని నేను పేజ్ టేబుల్ లో మెయింటైన్ చేయాలి? n pages. Is it correct or not? Are you clear about this? So కానీ ఇక్కడ ఉన్న ప్రాబ్లం ఏంటంటే ఈ పర్టికులర్ P11 ఈ పర్టికులర్ ఫ్రేమ్ లో P1 కి సంబంధించిన పార్ట్ ఉండొచ్చు, ఈ పర్టికులర్ ఫ్రేమ్ లో P2 కి సంబంధించిన సెకండ్ పేజ్ ఉండొచ్చు, దీంట్లో P3 కి సంబంధించిన ఫోర్త్ పేజ్ ఉండొచ్చు, దీంట్లో P1 కి సంబంధించిన ఫిఫ్త్ పేజ్ ఉండొచ్చు, దీంట్లో P2 కి సంబంధించిన ఫిఫ్త్ పేజ్ ఉండొచ్చు, దీంట్లో P1 కి సంబంధించి సిక్స్త్ పేజ్ ఉండొచ్చు, దీంట్లో P3 కి సంబంధించిన ఫస్ట్ పేజ్ ఉండొచ్చు. సో ఇప్పుడు 1 2 3 4 5 6 7 అవి కూడా ఏంటి, P1 P2 P3 కి సంబంధించిన పేజెస్ ఉన్నాయి. ఇస్ క్లియర్ ఆర్ నాట్? సో ఇప్పుడు నేను పేజ్ టేబుల్ ని ఎలా మెయింటైన్ చేయాలి అంటే, ఇప్పటి వరకు నేను P అండ్ F ని మెయింటైన్ చేస్తాను. P అండ్ F, పేజ్ నెంబర్ అండ్ ఫ్రేమ్ నెంబర్. కానీ ఇప్పుడు నేను కొత్తగా ఏం మెయింటైన్ చేయాలి ఇక్కడ? ప్లీజ్ ఎనీబడి కొత్తగా ఇంకో కాలమ్ యాడ్ చేయాలి, బికాస్ దీస్ పేజెస్ బిలాంగ్స్ టు డిఫరెంట్ ప్రాసెస్. I need to identify each page individually to whom this particular page belongs to, because from now in inverted paging, page table is only one page table, only one page table will be maintained. So appudu em cheyali exact ga, very good, 201 Sanjay, you're exactly correct. So you have to maintain process ID. Okay, so process ID. Now how many rows will be there in the page table? How many rows there in the page table? Equal to, so number of rows in the page table equal to number of rows in the page table equal to enundali. Yes, exactly, number 71, you are correct. Number of frames, number of frames ennaithe unnayo and so this is also n. Okay, so ikkada em chestundi eppudu kuda ni first frame process ID. Okay, actually ఏంటంటే పేజ్ నెంబర్, ఓకే. సో ఫస్ట్ ఏది ఉంది, ఇది ఫ్రేమ్ 1 కదా, ఫ్రేమ్ 0 కాబట్టి సో F0 ఏముంది అందులోని, P1 ఎవరికి సంబంధించింది 1. నెక్స్ట్ F2, F1 లో ఏముంది, F2 లో F1 లో ఏముంది, F1 ఏముంది, P5 ఫిఫ్త్ పేజ్ ఎవరికి సంబంధించింది, సెకండ్ ప్రాసెస్. P25 P2 కి సంబంధించిన ఫిఫ్త్ పేజ్. నెక్స్ట్ F2 లో ఏముంది, P4 ఎవరికి సంబంధించింది, థర్డ్ ప్రాసెస్ కి సంబంధించింది. ఇట్స్ క్లియర్ నాట్? నెక్స్ట్ F3 ఫ్రేమ్ 3. నెక్స్ట్ ఎవరున్నారు అందులో, P2 ఎవరికి సంబంధించింది, సెకండ్ ప్రాసెస్ కి సంబంధించి. నెక్స్ట్ P6 1 కి సంబంధించి, ప్రాసెస్ 1. PIDs, these are represents the process ID. Then 1 P1 ఎవరికి సంబంధించిన P1, థర్డ్ ప్రాసెస్ సంబంధించింది. నెక్స్ట్ P5 ఎవరికి సంబంధించింది, ఫస్ట్ ప్రాసెస్. సో దిస్ పర్టికులర్ పేజ్ టేబుల్ యాక్చువల్లీ ఎన్ని ఉంటే అన్నీ ఉంటుంది. సో దిస్ ఇది ఉండదు. సో హౌ మెనీ 0 1 2 3 4 5 6. Here how many, 0 1 2 3 4 5 6. సో ఇక్కడ 6 ఫ్రేమ్స్ ఉన్నాయి కాబట్టి ఇక్కడ 6 పేజ్ టేబుల్ 6 రోస్ ఉంటాయి. సో ఫస్ట్ కాలమ్ వచ్చి ప్రాసెస్ ఐడి, సెకండ్ కాలమ్ వచ్చి ప్రాసెస్ పేజ్ నెంబర్, సారీ PID means process ID, P means page number, F means frame number. Okay, so now ఇప్పుడు ఈ ఫ్రేమ్ సైజ్ ఏదైతే ఉందో ఆ ఫ్రేమ్ సైజ్ తోటి I will divide the main memory, sorry, the process into pages. I will divide the process into pages with the frame size. So frame size kuda nenu for example yes anestunanu. So here the yes frame size is yes. Okay, so P3 kuda with the frame size, with the frame size. So now the process are divided into pages, but the page size equal to frame size. Is clear? So now what the CPU will generate? Now it will generate three parts: PID and page number and offset. Okay, now here the key is dual parameter key. Now the key is dual parameter key, PID and page number. Maybe you already know about the hashing, dual key, hashing with dual key. Okay, so the same concept will be applied here. The first one is PID and second one is page number and third one is offset. Now with this dual key it will look into this. It's clear or not? So P25 కావాలనుకున్నారు అనుకోండి, then yes it is there, P25 is there. P25 ఏం ఇండికేట్ చేస్తుంది? సెకండ్ ప్రాసెస్ లో ఫిఫ్త్ పేజ్, సెకండ్ ప్రాసెస్ లో ఫిఫ్త్ పేజ్. నౌ సెకండ్ ప్రాసెస్ లో ఫిఫ్త్ పేజ్ ఎక్కడ ఉంది? F1 లో ఉంది. Then F1 will be returned. Okay, frame number, and then this offset will be transferred as it is, and with this it will enter into frame number. So now this is the logical address and this is the physical address. Is it clear or not? Is inverted paging is clear? Now I will consolidate again. Now in actual paging, process will be divided into pages with some page size, fixed page size. With the same page size, main memory will be divided into frames, and then the page tables are generated for each and every process, and it will be maintained in the main memory. But in the inverted paging, exact opposite. What it will do is, in this, the operating system will first decide the frame size, yes, and with the frame size, the main memory is divided into number of frames. If n number of frames are divided, the main memory is divided into n number of frames, then it will generate the page table. Here the page table is only one, common to all the process. Why? Because it will ultimately what the system is doing is it is maintaining only how many number of frames are there, those many pages information has to be maintained. So no need to maintain individual page table for each and every process. No need to maintain individual page table in main memory, individual page table in the main memory. Instead of that, a common page table will be maintained, but definitely it is larger, but it is only one page table is sufficient. So in that, because it is common to all the process, so to whom the page is belongs to, so to identify uniquely, I have to add page process ID, page number and the frame number, the three columns. Now, please remember, these three columns to part to page structure lo manam cheppukunnam. What are the other parameters? So frame number, process ID and page number to part inke untai. Please anybody? Valid bit, reference bit, dirty bit, and then protection. Even common. All these are common. So protection bit 2, dirty bit 2, reference bit 2, valid bit 2, all these are common. But కొత్తగా ఏమవుతుంది P బదులు it was divided into PID and P. PID and P and the frame number. And the frame number. PID, P and the frame number. That is the only thing. Okay. So the remaining structure will be as it is. So like this, your inverted paging can be implemented. So I will try to show you the architecture, a clear architecture. So please see this logical address. This is the process ID, page number, and the offset. Process ID, page number, and the offset. So this is the process ID, and this is the page number, and this is the offset. Okay. Now, with the process ID and page number. Okay, with the process ID. So PID and page number, it will look into the page table. So this page table is common to all the processes. So with PID and P, it will return the frame number. So here the frame is F, and F and D is exactly transferred here, and the physical address will be returned, and these are the different frames. So this is F0, F1, F2, and so on, Fn. So here the number of frames, number of rows in the page table are n. Is it clear? So this is how the inverted paging can be implemented. Is it clear? So now, demand paging. Is it clear? Shall I go for the next concept? Is inverted paging is clear? If you have any doubt, you can ask me. Emma, ఇప్పటి వరకు swapping, without swapping, with swapping, free space management techniques. Okay, paging, speeding up paging. Okay, page table structure, multi-level paging, and then inverted paging. These are the concepts that we already covered. If you have any doubt, you can ask me. If you have any doubt, you can ask me. Otherwise, I'll go for the next concept. The next concept is demand paging. Actually, this is paging, but till now we discussed about what is paging. So now, how the paging will be implemented? How the paging will be implemented actually by the operating system? How the paging will be implemented by the operating system? So now I'll try to clarify. Okay, so actually till now we discussed paging. So what I am telling, if the process is there and the main memory is there, main memory is divided into frames. Sorry, first the process is divided into pages, and the main memory is divided into frames. F0, F1, F2, F3, and F4. Then P0, P1, P2, P3, P4, P5. Then CPU will generate the P and D, and this is the page table and page number. 1. How many are there? 6. 2, 3, 4, 5, 6. Please try to understand the concept. Paging lo em chestunna nenu page number ni mundu chestunna. This is called logical address. I need to ultimately generate the frame. F and D. So this is called physical address. ఇప్పుడు వరకు ఏం చేస్తున్నాను, పి ఉంది ఇక్కడ, ఫ్రేమ్ నెంబర్ ఉంటుంది, ఫ్రేమ్ నెంబర్ డిఫైన్ రిటర్న్ చేసేస్తుంది. సో రిటర్న్ చేసేస్తే ఫ్రేమ్ నెంబర్ అండ్ ఆఫ్సెట్ యాజ్ ఇట్ ఈస్ గా ట్రాన్స్ఫర్ అయిపోతుంది, ఫిజికల్ అడ్రస్ వచ్చేస్తుంది అంట. బట్ యాక్చువల్లీ వాట్ హ్యాపన్స్ ఈస్ no page is readily present in the main memory frames. No page is available in the main memory frames readily. Whenever requested, whenever a page is requested or demanded, then only the page will be occupied in the free space, free frame in the main memory. Okay, then that particular information will be updated into the page table. That information will be updated in the page table. Sorry, that information will be updated in the page table. Okay, so that concept we'll call it as demand paging. So what the demand paging is, whenever a page is requested, in the paging concept, no page is readily available in the main memory frames. Actually what happens is, whenever a page is asked, then it will see that if the page is there or not. If it is not there, it has to bring that particular page from the hard disk. Actually where the process is, it is there, where the pages are in the hard disk. Okay, now this particular part of the page should be loaded into the main memory frames. Is it clear? So whenever the page is demanded, the requested page is loaded into the main free frame, then it is called demand paging. That's the reason it is called demand paging. So in paging, no page is readily available in the main memory frames. Is it clear? So how to get that particular page into the main memory frames? So that procedure, we'll call it as page fault. To get the required page from the hard disk and load it in the main memory free frames, and update that particular information into the page table is called page fault. Is clear? So how it will be happened is, I'll tell you. So now the CPU is trying to generate the page number and offset. So maybe for example, page number 5, offset is some 8. So now, is page 5 is there? No. Page 5 is not available. All the frames are free frames. Initially, all the frames in the main memory are free frames. Is it clear? So, what page is demanded? 5th page. Is 5th page is there in the main memory? Sorry, in the hard disk? Yes. Then it will look into this. So here the P0, P1, P2, P3, P4, P5. It will look at it. Is P5 is placed in the main memory frames? Is anybody? No pages are there in the main memory frames. No pages are there in the main memory frames. Then is page P5 is available in the frame? Is P5 is available in the frame? In the main memory? Is P5 is available in the main memory frames? No, because all the frames are free. Here all the frames are free. Is correct or not? Sanjay, please try to understand the concept. Initially all the frames are free, I am telling, and CPU is requesting for page 5. CPU is requesting for page 5. And is page 5 is available in this? in these free frames, is available in this free frame. Okay, here the page numbers are there. All the frame numbers are empty now initially, because no P0 is not loaded, P1 is not loaded, P2 is not loaded. Is clear? P5 is not loaded. So that's the reason why I'm keeping dash here. So is P5 is available in the main memory frames? Is P5 is available in the main memory frames? What about the other? Please respond. Is page number 5 is available in the main memory frames? No, it is not available. So now immediately it will return. How should I know that page table? How the page table will identify page is not there in the main memory? Please tell me. There are 3 bits. There are 3 bits: valid bit, reference bit, dirty bit. Is it correct or not? Okay. So page is there or not? How to identify valid bit, reference bit, dirty bit? Lo ye bit cheptundi. Page is there in the main memory frames or not? Which bit will represent? Yes, valid bit. So initially all the bits, all the valid bits are 0. Now నేను దేని గురించి చూస్తున్నాను? P5 గురించి. Is P5 is there in the main memory? Valid bit ఏముంది? Is P5 is available? What is the valid bit? 0. So it will not return the frame number. How it will return the frame number? It is not there. Main memory frames lo లేదు కాబట్టి frame number ఎలా రిటర్న్ చేస్తుంది? It may not. It will not able to return the frame number. So that is the valid bit. So if the valid bit is 0 and you are trying to access the P5, then it will raise a trap. It will raise a trap to the operating system. It will raise a trap to the operating system. That trap I will call it as page fault. The trap I will call it as page fault. If any page is requested, its corresponding valid bit is set to 0, then it will raise an interrupt, and that interrupt I will call it as page fault, and that page fault will be transferred to the operating system. Then what the operating system has to do? Oh, the CPU is waiting for P5. Okay, is requesting for P5 in the process P1. P1 కి సంబంధించిన 5th page ని చూస్తుంది. Then operating system immediate గా hard disk లోకి వెళ్తుంది. Is P1 is there? Yes. Is having the 5th page? Yes. Then it will return back P5. Then it will come back to the main memory. It will come back to the main memory. Then it will check is free frames are available. Is free frames are available. Initial ga enti condition ikkada? Initial ga enti condition? All the frames are initially all the frames are free frames. So your operating system will select any one frame and the P5 5th page will be placed. For example, F2 lo pettinది అనుకోండి. Then immediately the operating system, once the P5 is loaded into the main memory frames, then immediately it will send information to the page table. And now this valid bit is set to 1. And here the frame number is F2. Valid bit is set to 1 and the frame number is F2. Then immediately, so P5 అడిగింది కదా, P5 అడిగినప్పుడు ఎందులో ఉంది F2. Then immediately it will transfer the, it will retrieve, it will returns the fifth frame, and 8 will be transferred as it is. So fifth frame lo 8th instruction. So fifth frame, sorry, fifth frame kaadu, second frame lo 8th instruction. Immediately it will go into the second frame and then eighth instruction will be executed. This particular concept will call it as demand paging, and raising the fault will call it as page fault. So this particular procedure will call it as page fault, handling the page fault. Is it clear or not? I'll try to explain you again. Actually, in demand paging, in paging or demand paging, paging or demand paging both are same. Either you may call it as paging or you may call it as demand paging. Why particularly you'll call it as demand paging means no pages are available readily in the main memory frames. Whenever the page is called, then only that page will be placed in the main memory frames, one of the main memory free frames. Is it clear or not? If the page is available in the main memory frames already, it will be utilized. Is it clear? So now, so the procedure demand paging lo em chestunna ante, the first step is the CPU will generate the page number, and initially all the frames are free. Then it will look for the page which is there in which frame the page is available. Then it will see the valid bit. So then valid bit is set to 0. Then immediately it will raise a trap. The trap I will call it as page fault. Then immediately the page fault will be handled by the operating system. Then operating system will, what is the fault? Why fault is happened? For the P5 page. For the P5 page, the fault is happened. So immediately it will look into the hard disk that the P1 process sambandhinchina P5 fifth page is there or not. It will check. Yes, it is there. Then immediately that page will be loaded into the free frame. Is it clear? So the free frames are available. So that's the reason why it will select one of the free frame and it will be loaded. The fifth page is loaded, and that information in which frame that page is loaded, that information is immediately updated in the page table, and valid bit, its corresponding valid bit will be set. Is it clear? Then that information will be given to the CPU. Then CPU will ask again P5. Then now what happens? Valid bit is 1, so fault will never occur. Page fault will never occur because frame is allocated. The page is allocated to the frame. Then immediately the frame number will be returned, and offset will be transferred as it is. Then physical address will be transferred. So logical address into physical address will be converted. So that's the reason it is called demand paging. In demand paging, always it will raise a trap for the required page. If it is not there in the main memory frames, then the page fault will rise. That fault will be handled by the operating system, and the requested page will be placed in the main memory frames, and that information will be updated in the page table, and again it will be informed to the CPU, and CPU will ask again for the same page, and then the frame number will be returned. Then logical address will be converted into physical address. With this physical address, it will look into the main memory frames, and that fifth page will be executed. So this I'll call it as page fault handling in demand paging. Is clear? So in detail, so if you have any queries or anything, I will discuss in the next class. Okay, thank you very much.